In exercise 3, we have the following problem. You have $100 to spend on food and clothing. The price of food is $4 and the price of clothing is $10. In A, we're asked to graph our budget constraint. So let's do this. So we have two goods. We have food. So just for notation, food quantity I will denote this by F, and clothing quantity I will denote this by C. Okay, so the price of food is $4 and the price of clothing is $10, and we have an income of so we have income of $100. The price, so price food is $4 and price clothing per unit is $10. Okay, so let's draw the coordinate system first. Okay, so I will put clothing on the x-axis and food on the y-axis. So for clothing, I will start with 2, then I will have 4, the next will be 6, then it's 8, and 10. Oh, sorry, this was wrong. 8 and 10. So this will be clothing, so C. And on the y-axis, we will have food, and food will have steps of 5. So we will start with 5, then 10, then 15, 20, and then 25. So how do we draw this budget line? So what we need to find out again, as in the exercise before, so exercise 2, we need to find out the intercepts. And the intercepts here have a kind of an intuition. So the budget constraint intersects with the coordinate system, so with the lines here, with the axis, at the points where we are spending all our income on only one of the goods. Okay, so we need to find out how much we can maximally consume if we spend our income on one of the goods. So for food, so how much food can we consume maximally? So this is quite simple. So you have $100 and divide this by the price of food. This is 25. So if you spend all your income on food, you can consume 25 units of food. Sorry, I forgot the F here. So this is the amount of food. So 25 will be the intersection point here. And the same thing for C will be $100 divided by the price of clothing, which is 10. And then we have 10 here. And this is the intersection of the x-axis with the budget constraint. Now, if we connect them, this will be the budget constraint. So a feature of the budget constraint is that any of the points on the budget constraint, so any point that you can think of, the point here, or the point here, or the point here, all of them are bundles or combinations of food and clothing such that all of your income is spent on food and clothing, okay? So this means that at any point below, so any point here, you are not spending your whole income, on food and clothing, and on any point here, you are basically, you don't have enough money to, or enough income to buy those bundles of food and clothing. Okay, so this is the budget constraint. Let me just get rid of those things. Okay, so this brings us to sub-exercise B. So now we have the following situation. The government is subsidizing clothing such that for the first 5 units of clothing, we have, so the first 5 units of clothing, the price of each cloth unit is half. So it's not $10 anymore, so it's $5. And now we ask to graph our budget constraint for this new situation. And this is what we will be doing now. So let me copy this coordinate system here real quick. So this is sub exercise B. This here was A. So, sorry, it's not copied anymore. I have to do it again. Okay, so now we have a slight different situation. Just make this bigger. So why do we have a slight different situation? Yeah, because let me just correct this here. Because now for the first 5 units of clothing, we will have a different price. Yeah, so I will expand this here. So the budget constraint will have a kink because the price will change depending on how much clothing you're consuming. Good. So the important points will be at the intersections and the kink, like the position of the kink, basically. And the kink will be at clothing equal to 5. So I will put a 5 here. So the maximum amount of clothing that you can consume, of food that you can consume will not change. So the point that we had before, the intersection will still be here. Okay, so this will be still the intersection point of the budget constraint with the y-axis. So if we think about relative prices, the relative price of food and clothing will be equal to minus 1.25 as long as you're consuming 5 units of clothes or less. So let me just write this down here. So price F is still $4. So if C smaller than 5, then $5 if so smaller or equal. If C strictly larger than 5, then $10. So the question now is, if we consume exactly 5 units of clothing, how much can we spend on food such that we are still on the budget line? Okay, so if we spend $5 for each unit and we consume 5 units of clothing, we spend $25. Okay, so we spend $25 on clothing. Therefore, we have $75 left for food. And now we need to calculate how much food we can buy with $75. So this is then 75 divided by 4. And this gives us 18.75. And I would say this is roughly about here. Now, if we carefully, okay, this is not linear here, but let's assume it is. If we carefully connect the points here, we will have the kink exactly at this point here. And all we need to do then is we need to connect the points here, which gives us the first part of the budget constraint. And then we need to find out what the maximum amount of clothing is that we can afford under this new price schedule. So think of it in the following way. For the first 5 units, you pay $5. So this is $25, which means you have $75 left. And for the next units of clothing, you will pay $10. Therefore, we take the $75 and divide this by 10. And this gives us 7.5. So in addition to the 5 units of clothing that we bought up until this point, the kink here, we can still buy 7.5 units of clothing more, such that we at the end spend our whole income for clothing under this new price schedule, and this will be at 12.5. So at 12.5, we will have the maximum amount of clothing that we can afford under this new price schedule. So now if we connect the points, oh, this was too short. Yes, so this is kind of the new budget constraint, and you have it's a little bit difficult to see here, but you have a kink here at this point. You have a kink here, and the idea is that the relative price at this point is 1.25. So this is the relative price here, and the relative price here at the situation where you are basically paying the full price for clothing is then 2.5. Okay, so 2.5. Sorry, let me write this a bit more nice. So relative price. This is also the relative price. So as you move along the budget constraint, the slope of the budget line is changing because the relative price of clothing increases since the price is then $10 instead of $5. Good. Let's go to sub exercise or exercise number 4. So 4 is kind of a general exercise. So we are asked to explain why a consumer's optimal choice is the point at which your budget constraint is tangent to an indifference curve. And I partially gave some hints on this already in one of the exercises before. But now let's be a little bit more precise. So I think if you have a graphical solution for this exercise, this gives you the best intuition. So let's simply assume that there are 2 goods, and let's draw kind of a coordinate system and a budget constraint for this. So let's assume we have good x1 here. Okay, this doesn't look good. So on the x-axis, we have the amount of good 1, and on the y-axis, we have the amount of good 2. So this is just an example here. So this is question number 4. Let's just put some. I'll not even put numbers here. We'll just those are just some units, or we can put numbers here. Doesn't matter actually. So 1, 2, 3, 4. So let's now draw a kind of an arbitrary budget line, which goes somewhere from $4 to. Oh no, this is not a line. So this is a budget constraint. And now the statement is that if a consumer is maximizing his utility function, whatever his utility function is, then the solution will be such that the budget constraint will be tangent to some indifference curve. Yeah, so let me see if if my app here can draw indifference curves in a nice way. Oh yes, it does. Very good. So this is an indifference curve, and the statement is that at a point where the indifference curve is tangent to the budget constraint, we basically have our solution. So this would be the point here. Another question is why. So let me just go through the different features of this coordinate system that we have here. So a budget constraint, so the budget constraint, the red thing here, just represents all the bundles which you can just afford. So which make you spend all your income on the goods which are available on the market. The indifference curve is basically representing all bundles which give you the same amount of utility. Yeah, so for any point on this utility on this indifference curve, so any bundles that you can have on this indifference curve here. So if you make kind of if you have a dot here on the indifference curve, this corresponds to a particular amount of good 2 and a particular amount of good 1 that you can consume. And this gives you, so this dot here, which is here, gives you the same utility as any dot here. Yeah, so you're indifferent between all the consumption bundles which are on the indifference curve. Now the question is, why does it need to be tangent to the budget constraint? Okay, so let's suppose the following situation. Let's suppose we have an indifference curve which looks a little bit like almost the same as this one here. Okay, so and this indifference curve is here. Okay, so it's inside the budget constraint. So, and we are consuming a bundle which is here. So now the question is, can this be an optimal point? Can this be an optimal consumption bundle? And the answer is, as long as the utility function of the consumer is strictly increasing in the amount of goods that he's consuming, this cannot be optimal because all the points which are here, like in this direction, up to the budget constraint, which is here the red line, are feasible, so the consumer can consume them, and they give him higher utility, so they will yield a higher indifference curve than the point here. Okay, so anything which is below the budget constraint cannot be optimal. Okay, so like let me just draw it here. So this is kind of the yeah, let me just write. Let's call this A, this area. So any bundle in A cannot be optimal since the consumer can afford more goods. Okay, so this is the reason why anything in A cannot be optimal. Now, the next straightforward, so let's call this first. So second, what about anything which is like not on the budget constraint, but which is like on the right upper hand side? So let's call this B. So B would be everything which is like here and here. So B. So this is quite simple. So any bundle in B cannot be optimal since since the consumer cannot afford them. So if you write down an optimization problem, you will maximize the utility function of the consumer with respect to the goods which are available, such that the budget constraint must be fulfilled with equality. You cannot consume bundles which you cannot afford. So this is the simple answer. Yes. So any bundle in B cannot be optimal since the cannot afford. Okay, this is not good English here. Since the agent or the consumer cannot afford them. Okay, so this is the explanation why it needs to be tangent. So anything which is in the set B cannot be consumed because you cannot afford it. Anything in A is also not optimal because you can consume more of the goods and have reach higher utility. Yeah, so this is the reason why it must be a bundle which is tangent to the such it must be a bundle such that the indifference curve is tangent to the budget constraint.